Good day, Miss and fellow classmates. Today I would be discussing the concepts in holistically transaction management and concurrency control in my own words. For concurrency control is how a database makes sure that when many users access or modify data at the same time and everything stays accurate and consistent regarding that data. An example of this, imagine a shared Google Doc where 10 persons are editing that document at once, right? Concurrency control is like the system that prevents people from overwriting each other's work and causing chaos, right? It keeps everything synchronized and establishes an order and structure. Secondly, for loss update problem, in simple terms, this happens when two users read the same data and update that data, but one update overrides the other, causing one change to be lost. For example, imagine a friend and I editing a bank balance. The initial balance is $100. I withdraw 20 and then remaining of $80. My friend deposits $50 and calculates 150 afterwards. Now, if my update says last, the bank balance becomes $80 instead of $130, and my friend's update is now lost. Thirdly, uncommitted data problem. So this occurs when a transaction reads data that another transaction has not yet been finalized or has been committed to, and that data might later become undone. Right? For example, waiter A for a restaurant order system enters a customer ordered steak has not yet been confirmed, and waiter B sees it and starts preparing the steak. Then waiter A cancels the order. Now the steak is being made for an order that has never existed, and that's using uncommitted data. Inconsistent retrievals. Now, this essentially happens when a transaction reads data while another transaction is modifying that data, leading to inconsistent or partial results. For example, checking a bank account. You see that the savings is $500 total. At the same time, the system is transferring $200 to checking. Then you see the checking is $300 post that bank transfer. Now, your total looks like $800 instead of $600 because you saw a mix of old and new data. Transitioning into lock and lock granularity, which are two different definitions and concepts. Lock, right, is when a database temporarily blocks others from accessing data while one transaction is using it. For example, let's say I am editing a file and that file is locked because Christian is editing it, right? And others must wait until I am done so that they can edit one by one. For example, my classmates. Now, on the other hand, lock granularity refers to how much data is locked, whether it's a small piece of data or a large chunk of data, right? So locking one row of data, which is fine-grained lock, and coarse-grained lock, locking an entire table. For example, a library system, you borrow one book and others can still borrow other books. And then the other one, you're locking an entire table, you block access to the entire shelf of books where no one else can use it. Transitioning into the final point, which is two-phase commit protocol, 2PC. This means, right, that it is to ensure that a transaction involving multiple systems either completes everywhere or it fails everywhere, and there's no partial updates, there's no middle ground, right? For example, how this works, phase one is preparation, where all systems are asked, are you ready to commit, right, to the task? And phase two is you either commit or you abort the task and the mission, right? So if all say yes, it fully commits. If all say no, it rollbacks everything. For example, when transferring money between two banks, Bank A, right, you're deducting $100, Bank B, you're adding $100. The 2PC method ensures either both happen or neither happens. There's no situation, right, where money disappears or duplicates. And this is my understanding and explanation of these definitions with its relevant examples. Thank you, Miss and classmates.